Hello and welcome to Chapter 4, Supporting the Power System and Troubleshooting Computers. So today, on this lecture, you're going to learn how to purchase a power supply. How much do you need? What kind of power supply do you need? How much power and everything that you need to know about power supplies. And hardware problems, what kind of hardware problems your system might have and what you can do about that. All right, just don't forget that I'm going to ask you to write a few notes and submit them as homework. So don't forget to do that. All right, to keep the system cool inside, you have to make sure you want to keep the system cool inside the PC by keeping the case closed, clean the inside with compressed air, and move the PC from dusty or warm areas. All right, make sure you write that down. The system has to be cool, otherwise you'll have overheating. So keep the system cool inside by keeping the case closed, clean the inside with compressed air, and move the system from a dusty or any warm areas. All right, another note that you should know about is a heat sink is made up of some metals. I don't know if you've seen them. These are fans, but you can have heat sinks that's made up of metal that draws the heat away from the processor into the fins, and then the fan then will blow the heat away, right? We need to do that. Liquid cooling is a small pump you can have to cool the system. Then you can have liquid cooling, which is a small pump that sits inside the computer case, and tubes move liquid around the components and then away from the system to replace where the fan's cool liquid is. This is similar to what the car used to have. The car radiators work. All right, so make sure if you turn the system on and you don't hear the fans running, turn it off. That means if they're unplugged, you're going to get overheating very quickly. All right, so let's talk about now selecting a power supply. All right, so number one, please write the following down when you are selecting a power supply. The power supply, by the way, remember, just to give you a quick review of what the power supply is. Why do we need a power supply? It's to convert the AC power that's coming out from the wall outlet, convert it to DC power. And the most common 3 DC volts that comes out of the power supply is 3.3 volts, 5 volts, or 12 volts. So the SATA gives out the 3.3, 5, and 12. The Molex gives 5 and 12. And the P1, the 24P1, is 3.3, 5, and the 12 volts. So your power supply has to be able to provide these 3 level of voltages. All right, so when you are purchasing a power supply, the first thing you need to do, write this down. You need to determine, is it for ATX or micro ATX form factor, right? Because otherwise it won't fit sometimes. The wattage rating, that's very important. Of course, this is going to tell you how much the maximum load is. For example, if you purchase 850 watt power supply, that means the power supply can provide 850 watts to all of its components. Once all of these watts are given out, that's it. If you add any more component to your PC, the system will shut down because it knows it's going to be overloaded and it won't be able to provide wattages for anything. So if you added a new system, a new device on your computer, and you turn your computer on and your computer doesn't power up, but when you remove that component out, it powers, that means you don't have enough wattage. For example, a hard drive can use up to 50 watts. A video card can draw up to 400 watts. So you got to think about all of that when you are purchasing a power supply. And always, this is a rule of thumb, please write this down next to number 2, always buy 30% more wattage than you really need. All right, you need to also decide on the number of connectors that you may need. All right, how many connectors you need. Don't buy, because a lot of cables inside also may prevent the airflow as well. So be very careful. So it's not always a good idea to have, 500 million cables inside your PC. Fans inside the power supply unit. You know, how many fans are there? Dual wattage options, 120 and 220 volts. You need the 220 volts if you're, somewhere maybe in Europe or somewhere else in a different country. They use a different wattage area. So you may need that. And any other extra features that they have in there. Okay? You can read that up if you want. Now, so to calculate how much wattage, just add up everything that you think that you're going to have on your PC and add 30% more, like I said. Okay, so here are the different types of approximate wattages that each of component uses. Here is the case on power supply manufacturers, a whole bunch of them. If you're thinking about building your own system, so you buy the tower, and the power supply usually comes with it. All right, now let's talk about troubleshooting. All right, you can go through this general approach diagram, this flow chart, step by step. Probably a good idea to go through it. But there are 6 steps that I want you to write down in general, and the chapter goes through each step of them, each step 1 to step 6. So write those 6 steps down, and we'll discuss them. So the first step is going to be interviewing the user and backing up the data before you make any changes to the system. So when something goes wrong, the first thing you are going to do is ask the user what went wrong, and ask all of these different questions. You got to, verify, examine the system. All of these 6 steps I want you to write down first. Okay? Now you can do all your research, but each step requires a lot of work, of course. You got to do a little bit extra work to get to each of the steps. But the more gathering information on step number 1, the more you have, the better off you're going to be. All right? So let's go over step number 1, interviewing the user and backing up the data. You want to be able to ask as many questions as you want. The more you gather information about what happened, when it happened, how did it happen, can you replicate the problem? You'll be able to, you want to pinpoint where the problem is as much as you can so you can save time in fixing it. All right, once you gather all that information, also before you do anything, you back up everything. You can back up the data just using Window Explorer, copy the stuff on an external drive, whatever. Make sure everything is backed up and ask the user if there's any important data that's in there that you really need to be moved before you try anything. All right, so step number 1, make sure you get as much as information you can and you back up the data. In step number 2, you want to examine the system and make your best guess in guessing what the problem might be, right? So examine the system, analyze the problem, make initial determination of the source of what the problem is. So you're trying to get and figure out what the problem is. Now, to be a good troubleshooter, it's really knowing how the system works, exactly how it works. That's why you need to really understand how the system operates. And then it's really experience more than anything else. The more experience you have about the different problems you get, the more you'll get better at this. So you can't be just a great PC troubleshooter by reading a book or never touched anything, never experienced any problems. So sometimes it's good to encounter some issues. This way you'll go through, but you want to go in a sensible, way of tackling the issue. So you don't want to just do anything and waste time. All right, so after step number 2, after you have examined the system, analyzed the problem, and you take a guess at what the problem might be, the next thing you are going to do is, in step number 3, you want to test the theory. You made a guess, you have some scenarios in your head that you want to do, so you want to test your theory. If the theory is not confirmed from another theory, or escalate the problem to someone higher in the organization that has more experience. If you don't know what to do and all your scenarios didn't work out, you let someone else take a look at it. All right. But the best thing to do when you have all of these different theories, scenarios, you go with the one that's going to take you the least amount of time first. and you try that out. So if, let's say, rebooting the system works, you go for that first, right? All right, so after you're testing your theory, you can go through this flow chart to pinpoint where the problem is. And now, this is important. So this table gives you step-by-step on page 181. So these are very good references to give you the symptoms and the error messages. So, for example, if the system shut down unexpectedly, this is something that you can try. If you got no power, this is something that you could try. So this is a good place to start with, guessing what the problem might be, right? So after you know what the source, plan on what you're going to do next. So you probably can visit this page and say maybe it can pinpoint you where the problem might be, right? And in step number 5, you want to verify that the problem has, supposedly you fixed it. And, well, before we even go on, this is another good place to be if you hear beeps. The power on self-test, which we'll discuss some other way when you boot up the system, when we get into the software part of this, this course, there's a power, when you're booting up your computer, there's a program called the Power On Self-Test, which is several diagnostic program that tests the hardware of the PC and make sure everything is where they're supposed to be. Now, if there's any problems with any of these hardware, you'll either get some beeps or get some error codes telling you that there's a problem and the system doesn't even go to boot up the operating system. It'll just hold. So by listening to these beeps or some of these codes, it can tell you what the problem might be. So this is another good reference point. So page 181 and page 183, the post error codes are something you should keep in mind as a reference. All right, so in step number 4, planning your solution and then fixing the problem. All right, after you fix the problem, of course, hopefully, you verify the problem is fixed, and then the system works. Take any preventive measures to make sure that the problem doesn't happen again. Very important. And the last step, which is extremely important, all right, document. You need to document all the activities, outcomes, and what have you learned. What are the pitfalls? What you are not going to do next time you encounter this problem. All right. So we'll stop right here and we'll finish part 2 of this chapter on the next video. So write down whatever I asked you to write down and submit that as homework. And I'll see you on the next video.